Okay, so in this contest, I'll try to do all the questions and let's see. If it happens, it will be the first time. There are n players playing a game in a circular table. This is to it, they take it fruit and play and go first. During the turn, player I, any misses remain, they must eat exactly one dish. Player starts their turn. Okay, so n is 1 and 3, right? 7 modulo 6. What is AI? Ith player has AI teaches to it. Okay, but then the player who has the maximum. Okay, well, so 1, 2, 3, 4. 1, then ith player has AI teaches to it. Take turn each eating food. Any player can go first. During their turn, if the ith player has teaches remaining, they must. Okay, the number of players who can possibly be the winner. So the maximum count. Yeah, simple. Now if a of I greater than max, then mx equals to a of I will change the maximum and will make the counter 1. Now else if a of I equals to the maximum, then we'll do incrementing the count. Now we'll output the count. Okay, don't save. Okay, still check this 1, 1, 2. 1, 1, 2. Okay, nice. Yeah. Next, Ask Lol Coding is playing a game of an array of n positive integers. During their turn, if AI is non-decreasing, the game ends. Okay. If A is non-decreasing, otherwise, then choose any single element and remove it from the array. Non-decreasing, so it must be increasing or flat. Okay. Determine the minimum possible number of elements that can be remaining in the array after the game ends. Non-decreasing. A is non-decreasing. So, because it has 1, this 1, it is 2. Non-decreasing, we have decreasing part. If A is non-decreasing, the game ends. Otherwise, determine the minimum possible number of elements. Okay. Non-decreasing means it will be increasing or same. Okay. In that case, there will be no inversion. Here 4 has 3 inversions. 4 has 3 inversions. 2 to the power 10. Okay. 4 has 3 inversions. This. Sorry, 4 has 2 inversions. That is it. So minimum one element can be achieved by removing 1, 2 and 3 in that order. 1, 2 and 3. A is non-decreasing. So it has a decreasing part. It will have one element. Okay, the game ends if A is non-decreasing. Yeah, in this case the game ends. In this case the game ends. So in this case the game doesn't end. It can be won. So if there is any decreasing part, the game will continue. So we'll just check the adjacent one. I think either it is n or it is 1. Previous must be -1. If now is less than previous, in that case cout 1 right and return. Else cout in. One 1 6. What 3 what 1 1 6. Oh, see in n is 2. Cout n. What? Oh, it is 6. Oh, got it. flag, then 1 else in 112. Is playing a game on a string s of length n. Initially, s contains only lowercase Latin letters. In one turn, choose any pair integer I and j such that in range, okay, si equals to sj and sk equals to star for all in between characters, that will be star. What? Okay, if no such ij exists in the game, otherwise, then the game ends. Otherwise, scroll sets s equals to star and s equals to star. Okay. S equals to sj. Once game ends, scroll will win if and only if every character in s is equals to star. So to win. Okay. In this case, no. Okay, I and j are distinct, so it will be a no. In this case, can make this whole. I can make this and this. Right. Yes. Okay. I will keep a base case and it will go along, right? Like this m, it will come here, from here it will go there, right? Yeah. So looks simple DP problem. Yeah, dynamic programming will be good for this. Take the string, then the DP to make it in one best index. I can keep it boolean now, the base case. J will be from 1 to j less than I. Okay, now wait, it will not contain any star, right? Okay, in that case it is okay. Okay, we do not need this. else case, no. Everything is no. Okay, this will be J minus 1. No, yes, yes, no, yes, yes. No, yes, yes, no, no, yes. Okay. Okay, this one is no. Okay, I missed one. Every character in between is also that star. We do this. Then do the star, star. I do this one. No, two. It doesn't characters are there. This case I. It will be star, star. Then this will be star, star. And then it will propagate. First of all, this will be these are, yeah. Then these, yes. Yeah. So you can do it in n square. 5000. Yeah, we can do it in n square. In each iteration, it will reduce by n by 2. I will not have s dot empty. S dot empty. Now we'll go from here. Okay, previous. Start size now. In that case, t dot pop back and I will be plus plus again. Else cases, else cases, t dot I think it's plus plus. Okay, I don't know. Else in every case it doesn't matter now. If no operation is done, then it is not necessary, but yeah. In that case, it will show no. In this case, it will show yes. What? Time will make it exited. Time limit exited. Interness t flag equals to false. Okay, got it. No, yes, yes, no, no, yes. We are given a permutation P of length n. There are also portals located at position X and Y. A portal at position I initially located between I and I plus 1th element of the array. Specifically, if I goes to 0, then portal is located before the first element of the array. And if I goes to n, the portal is located after the last element. I and I plus 1th element. Okay, if you may perform the following two operations as many times as you like. Remove the elements to the immediate left one. Remove the element to the immediate left one portal and insert it to the immediate right of the other portal. Remove the element to the immediate right of the portal to the immediate left of the portal. Let's denote the portal, for example, using one operation left and right portals respectively results in the array. Okay, so 3 is gone here, right? Yeah, and 3 can be turned back. Okay, okay. Find the lexicographically smallest permutation. 4 to 4 from here, then from here. Find the lexicographically smallest permutation you can obtain using these operations. Note that portals do not affect the lexicographical comparisons of permutations. Okay. X and Y portals are in a specific place. 0 and 4. Okay, this one 0 and 4. Okay, the thing that is inside it will remain the same, like 0 and 4. It will be first and the last. So the content inside it will remain in the same cyclic order as it is. Next, 1 and 2. So here and here 2 will remain same, and 1 2 3, right? No, 1 second and the third element, second and the third element, and here. Okay, 1 from here, right here, that will be 3 1 2. Or it will go from here to here, it will be it will be 2 1 3. It can go from here, get placed right here. Okay, okay. Or if we bring this one here, it will also work. So there are two cases, outside and inside. And it is a permutation. Okay, so it is easier. So inside it, inside those portals, it will be like taking the first element first to lexicograph, and it will, okay. So we'll try to take the first element first, right? Yeah, just two cases combined together. Now can be 0 to n. Okay, so it will start from the range from x to y is inside the portals. So now okay, visited a way of I plus plus everything that is inside it. Now we will try to make them shorter. Yeah. Okay, I also don't need this. Now write x equals to x. Not x. Now of k plus plus, not answer of k plus plus equals to a of I. Yeah. Perfect. Now the outside part. For outside we will okay, so the first element cannot be changed. Okay, lexicographical. So we will try to take the minimum there, and also might not be that might not be the A of I. Okay. Gotta keep it here. Then we'll take a sub part. Yeah, the whole thing we're changing just the order. So the first part is mn, right? Now and e of p less than, sorry, it will be greater than mn, we'll do p minus minus. Now p will be the position where p will be the position where okay, okay, it will take the minimum from 1 to x or the minimum there, right? Now this will be the minimum between the first and the x position. Yeah, okay. Okay, we can also change the idx right here. I have idx there. Idx equals to x. Now we'll change the idx. If mn is less than a of I, sorry, it is greater than a of I, it will then change to a of I and idx to I. Now push back then pop it. Now idx less than x, I plus plus, this will be the first part. Now the middle part. Okay, we also can make that, oh, right. We'll just try to make it better, and also do that. That it will be just after that position. This will be a different vector. We'll do this and we'll just add this vector, right? Yeah. Okay. So timing, calculate, I think, calculate No. We'll just add the outer part of the array. If I less than x and sorry or I greater than equals to y. In that case, pushback a of I also equals to 0. Okay. Okay, first we'll emin and emin2. Okay, but we need emin2 that can rotate completely. This cannot. Okay, this has to. No, this is no. If I less than x or I greater than equals to y. In that case, I'll compare. Like if a of I. Now we'll compare if a of I less than mn. Take a flag also. And not a flag. In that case, flag equals to true and we'll insert all those. Perfect. Now final the element in answer pushback element now else final dot pushback final dot pushback. One four two three two three one 6FG. Okay. I can make equals to y minus 1 6FG. Okay. If y equals to 0, no, x and y, so y cannot be 0. Y minus 1 is valid. Or will it be y? Now less than x. It is outside that. Okay, it is outside that. Yeah, perfect. Less than, greater than mn. No element in answer. Answer dot pushback element. Error 1423. Yeah, full array. Okay. In this case, I think 1423. It's okay. Now, if it is less than x or greater than equals to y, in that case it is comparing, otherwise it is not. Okay. Now, if flat auto element in answer final dot pushback element. I think it was the problem. 200 is the problem. 35. Okay, that is 2 only. It's 2 only. That is perfect. 2. The else the other things are not going on. Okay, this is not I equals to y. It's I minus minus. One, two, three, five, four. One, two, 1, 2, 3, 5, 4. 1, 2, 3, 5, 4. 1, 2. 4, 2. Alice and Bob are playing a game on array initially containing n positive integers, with Alice going first. On each player's turn, if AI is non-decreasing, the game immediately ends. Okay, AI is non-decreasing. A is non-decreasing. Otherwise, the player can choose an element x from the array, and positive integer is non-decreasing. X and positive integer such that x equals to yz. Okay. Replace x in the array with two elements y and z. No such move is possible. The game ends. Once the game ends, if A is non-decreasing, then Bob wins. Otherwise, Alice wins. Determine who will win the game if both plays optimally. The creator is case sensitive. And so 10, 9, 8, 7, 6, 5, 3, 2, 1. Alice. A is non-decreasing, the game immediately ends. Otherwise, Alice wins. First case, Alice will win. If both plays optimally. In the second test case, Bob can always win no matter what Alice. Okay, in the case 6 and 7, it is non-decreasing. So the game immediately ends and Bob wins. It is decreasing. Then he can make 6, 2 and 3. 2, 3, 5. Bob can win. It says Bob can win. Okay, first Alice makes the move. But if Alice makes the move. Okay, so 8192. 8192. 4096. 2048. Okay, so it's a power of 2. But Alice can make it non-decreasing. If it is non-decreasing, the game immediately ends. Otherwise, the player can choose an element x from the array. In this case, that case Alice can 3 and 2. Okay, 3 and 2. But the final thing is not non-decreasing, right? Yeah. Here, we can make this 5 and 2. That case, it is non-decreasing. So, it cannot be made non-decreasing. So, the first move will define the nature. Okay. This move, if we can't make any possible change, if the primes in that number and make it primes in that number, and okay, I think I got the idea. Okay, so the thing is, if we breaks it like like uh, like 30 in, so what will be the factors? 2, 3, 5. So if it breaks 30 in 10, 5 and 6, okay, no, it doesn't need to make that. We can break it like 15 and 2. That case also it will work. The case it will not work is where the number is a power of something like k to the power p. Where k is a prime. If multiple primes are there, can always do. Yeah, we can always do that. Okay, so how to check this? So the prime in this number, so we check the first case, if it is already not decreasing or not. If it is not, then for each number we will try to see if we can break that number into something like that. Then that is it. That's it. If we can break any number like that, Alice will win. Okay, so now we also need the SPF. Now otherwise we will do it Perfect. Now we'll pre-calculate this. After that, we'll check. Okay. Now I can get the factors from set. Inside insert SPF of file and right. Yes. Params dot size equals greater than 1. In if cases, P greater than any previous prime. In that case, Alice will win. In other case, Bob will win. Flag goes to false. pop pop Alice. First of all, this will be pop. Alice pop Alice. Okay. Wrong answer. Pop. Okay, in this case pop will win. What if I make it 1 3? 6 is like 2 3 and 1. It will also be pop. Miss Alice. Plus one is 1 1. Non decreasing. Okay, this can. Yeah, this will be Alice. We make 3 2. Bob. But no. It will be Alice. 3 2. To 0 primes. L equals to AFI. Primes to insert SP for fell. Into P equals to P equals to 1 primes int P equals to stop it P less than previous. Okay, I'm not changing the previous. So P equals previous. Alice. Okay. Yeah. Nuclear reactor. Okay. So produce the energy possible in a reactor. C has independent particles. Okay, now each particle is defined by two integers x and y. The particle generates x units of energy but has reactivity y, meaning that it can only exist together with at most y other particles in a reactor. Formally, if the particle chosen to generate energy, then at most y particles other than itself can also be chosen to generate energy. Basic must choose a subset of particles that satisfy this constraint to generate energy. The amount of energy that C generates is equal to the sum of the energies of the particles in the subset. Particles generate X units of energy but has a reactivity of Y. Y particles in the reactor. Okay. There's a SOP. There is a SOP with M particles. Basically, you can buy exactly one particle from the SOP. For each particle in the SOP, determine the maximum total energy base C would be able to produce if C were to buy only that particle from the SOP. It is not required to use the particle that is purchased from the SOP. Number of particles VC has and the number of particles in the SOP respectively. E, X and Y. The energy and the reactivity of base is ith particle. The energy and reactivity of ith particle. Okay, next M line. Activity of the SOP's jth particle. It is the ith the maximum total energy that BC can produce if she purchases ith particle from the shop. Only the ith particle. If he purchases this, he has 3, base 3, only 67 or 62 plus 7 is 69. Yeah, the answer will be this. So the thing is that if we can take only one value, we will take this. If we can take only two values, we will take that. Yeah, we will calculate that one and we'll take a maximum from here. Yeah, and this particle, choosing this particle, choosing the other X particles from here. Okay, choosing the other X particles from there. Or I can choose, I will not choose this particle, right? Yeah, okay, got it. So if it is like 7, then 1, only 1. We choose 2 particles. It looks like in square something. No, it is sorting based question. 67 and 6171. So 1. The maximum we can get, the better we can achieve. So from 3 we can take 2 of them. Okay. Y is from 0 to n. That is good. It starts from n. Yeah, that will always be that. Okay, y is 0 to n only, not n plus m. So taking all n elements. Cannot take all n elements. Take n such elements means taking n such elements means Okay. I think I can get this. So in such element, we'll take in minus 1 such elements. We'll add that to this value. Right. Yes. And in minus 1, in such element, I will keep one position, or we do not need to keep one position out of that. Yeah, just it. Yeah, in that case, we'll change the minimum by anything, and then we'll reduce that. So it might be priority queue. We'll keep the value, then we'll reduce it. Perfect. I think it is perfect. Okay. I think this code needs to be done right here. Yeah. In M, now okay, we'll make a struct, I think. The minimum value and total value. Now less than equals to n. Yeah, perfect. Now we will check on left to right. Okay, so let's sort them by this number in reverse order. Now the previous. Oh, okay. Take this. The previous value, let this be n and total be 0. Now while I greater than equals to 0, sorry, while I less than n and e of I equals to sorry, first previous, right, till then I have to do things. E of I plus equals to total plus equals to a of I second, right? And we are pushing the value. The priority queue must be the minimum. I think this is okay. Okay. Sorry. That will work. Yeah. Okay, so now we are pushing the peak queue. It will reduce the minimum one. Now we can also take size. I have increased the size. Now we have to decrease it. Greater than, we can set greater than value in value can be previous. Previous value, then yeah. Now they are not the same. It will not happen. They are not the same. Then is equals to this previous and that previous is not same. That previous is already covered. From here there is a new previous. That case finding the next thing that I don't think it needed. If it is not equals to previous, then previous equals to api dot first. Then it will go on. Don't even need this. Okay, after this we got the whole array, and in that case it will also get minus equals to q dot top. Now okay, now dp of previous is the number of times it repeats equals to first event then total. Perfect. Okay, now those things we can always make that. Yes, those things we can always make that. If it is less than, to increase the total. But if it is like, then what will happen? If it is like this whole thing is well balanced and this dpi minus 1 has one value which is very big. Okay, make with that, but we cannot combine. Okay, it will actually be from yeah. Perfect. Now total value. Now answer equals to dp of y dot total plus dp of y dot minimum plus x. Answer is like taking this value and checking the maximum possible score. $67. Okay. 178 is a problem. Yeah, not like that. Yeah, my answer. Perfect. Okay, now 6700, 762, 778, 14, 0. Okay, the 0, 67. I think I haven't calculated the 0. Okay, the size greater than previous. There can be any elements. Plus one elements also. There can be n plus 1 elements also. 1300, 769. 13. The sticking 100, 7. Why not 67? So 0 elements. So greater than 1 it cannot. So it's greater than 1, so it needs to be 0. It needs to be 1. That is number 67. So sorting them are begin right. Code R begin R end. Okay, so 0 first. Begin like end first. 1 6 0 67 then 0 1. Yeah, it is. For 0, so previous equals to n of I dot first not equals to previous, then previous equals to of I dot first. Right. Then check all those AIs. Previous equals to this one. Okay. Now is set greater than previous plus 1. Perfect. Perfect. looks perfect. It is not working. Okay, so previous equals to 1. First it takes previous equals to 1. 1, 2, 3, 5. Then it takes previous equals to 2. Previous equals to 1. If I dot first equals to previous. Total plus equals to f I dot second. Oh, okay. 1. 1, 7, 1. Total is 7. 6 and 7. So extra 1. Okay, 1. And take 1. Okay. Okay, then okay, the 2y plus 2. Okay, next. Seven hundred 714. Six 1. 1, 6, 1. Okay. Previous is 1. 1, 6, 1. Total is 6. It can take 8, 2. Total might not be. What? Okay. 32 minutes. Pick.top, it is not debugging. 6 and 1. The total is 6. I less than in I plus plus. Yeah, y dot first equals to previous. Okay. Y dot second. PQ dot push. Y dot second. I can debug. Total value is not getting decreased. Okay. First thing getting is okay, that is 6 1. It will be 6. But after that, 6 1. Okay. In that case, I think I should look for TP of previous is 1. Still look in 1. 8 1. 8 6 1. It has only 6. Okay, then we should always make if sz then pq dot push. Okay. It will report the minimum value. 1340. Seven and can get 0. Okay, to make minimum is 0, but that is not possible. But it is already filled. It is already filled. then we can do it here. If that still happens like 0, 6, then you have to have to pop that 0. Total minus equals to pq dot top. 6 and that decreasing. It gets 6, then 0 is total, and the pq dot top equals to 0, 6, and it is 0. But no, the number will not change. E minus 1 can take in values like 6, 0, 1. Total will change 30. Okay. The total will change. You should have calculated for each. Total plus equals to the value, then pq dot push that value to it and that extra 0, then is size plus plus and j plus plus. Now if size is greater than I plus 1, then size greater than I plus 1, total minus equals to pq dot top and pq dot pop and size minus minus and You have to also consider the case where zero LL and otherwise pq.top. Now dp of I equals to total comma mn. Okay, error. What if I say 7 and 2? Total mn comma total. Okay, total 714. 160. First needs to be 67. 5 equals to 0. First equals to I. Okay, it became yes, size plus plus j plus plus. Total minus equals to pq dot top. Zero 06 07 02 06 07. I is 0. Then it will pop 6. Then it will pop 7. Perfect. It needs to add 67. Total minus equals to 6 and total minus equals to 7. Put Okay, 1616067. What? I is 1. Okay, okay, 067 67 0 to second. Total plus equals to. But how is it then 1? Total 67. I think not answer. What maximum is equals to 1. I think we should get maximum is okay. I think that was the problem. Question E. Dot what? And X. TP of 5. Perfect. Maximum and answer. First case same integer, the ith integer should be maximum total energy. Purchases the ith particle from the shop. He purchases the ith particle from the shop. This looks correct. How is it wrong? 2 1 2 2 4 2 3 1. The answer is 4. Okay, now make this 2 and 174. Okay. Okay. That case. Four and 4 make it 5. Should be 4 and 5. Yeah, but okay, wait. 16 0. In that case, it is not working. Okay, no, it is working. But 16 12. In that case, it is not working. Okay. We have to take the prefix sum. We can add that element there also. Sixteen 12 is there. But consider that is from n to 0. If 12 works, then this also. 60 and 12. 0 it is working from. So okay, n cannot be 12. And why that can maximum n. 12 is 5. 5 2. Yeah, but 7 values. But yeah, 64 and 60. If it purchases the first one, 64. Otherwise, it's 60. One, 3. This is 61. And if it is now to be 67. Okay, this 2 then 77. What is it? Most why other in the reactor. Okay, the thing is that it can also happen like the other cases. It will take that value as input. Okay, got it. The maximum value and where we can add that, like must be greater than minimum, previous minimums. Okay, we have to take from 0 to I is possible probabilities. The minimum will be less than that. So the TP of I total minus min, that will be maximized. Okay, suffix. So it will be prefix. Prefix of 0 equals to TP of 0 dot total is TP of 0 dot minimum. Now this will be prefix of I equals to maximum of TP of I dot total is TP of I dot minimum plus new comma prefix of I minus 1. Okay, now this value and okay, up to that, right? Can always do prefix of y plus x okay. Run. F. Yeah. Okay, two questions left still. Okay, it is pretty good, I think. The time will get up right now. So let's recap the questions. Like the first question, eating game, it's I think let's see the questions too. Okay, so this was the question that says the player will possibly win the whole round, so it has to be maximum like eating in each round. Is eating in each round and it can start from any position. So the answer will be the maximum such number that exists in the array. So here the numbers are 4 and 4. There are two such maximums. So the answer will be 2. And this is it for the first question. Just finding the number of maximums in the array. Then the second question, it was like, okay, A is non-decreasing, then the game ends. Otherwise, you can choose any single element and remove it from the array. So any single element and remove it from the array. So if A is non-decreasing, the game ends. Now you can make the array non-decreasing. Okay, I am little bit confused right here. The minimum possible number of elements that can be remaining in the array. Okay, you can choose any single element and remove it from the array. So if like 4 2, it is a non-decreasing part. Sorry, it is a decreasing part. So you keep this part and delete every other numbers like 3 1 like that. Then you delete one number from here also like 2. So the whole array becomes a single number. That is why if any such inversion exists, then the answer will be 1. And if there is no inversion, like it's increasing, it is not decreasing, in that case the answer will be the whole array in the size of the array in. That is it. So flag checks if the now is less than previous, that is inversion exists, and then if inversion exists, then the answer is 1, otherwise the length of the whole array. Now the third question. Third question says IJK star. Okay, so you are basically replacing the characters with the stars. Now the first thing, you have to make two characters, the stars, right? And and the one thing that if n is odd, it can never happen. So first you make two characters like LL, then you make this LL star star, then you can combine this MM. So you can make this star and star, then you can forget about this part because M and M will act like they are adjacent to each other. So that is what I did, I guess. Yeah, in each step I am doing this and then making the new string t without pushing those stars in that position, and I'm just continuing this process. So I'm just simulating the whole process, and it was accepted because of those slow constraints, I guess. Now the next question, problem D. So the portal thing. Now the portal, in that portal there are two parts. Basically the inside part, like 2 4 and 2 4, it can rotate cyclically, right? And this, the left part and the right part. So the left part can go to the right part, like this part. There's 3 and 1. It came in that right position, and it can go, the right part can go to the left position. So that is what happened here, and you have to make this lexicographically smallest. So in the beginning of this phase, you will put the smallest number possible, right? So that can only happen, that can be this number or any number inside this range, because we can cyclically shift these numbers. And if this number is the minimum, the number that is in the left or the first of the right, if there is nothing in the left, then we'll compare this minimum with this minimum. If this is smaller, then we'll keep this part and we'll go on putting those values, the outside values of these portals. And if at any point, if this number, the minimum in the inside part, is greater than, sorry, is smaller than the number of the outside part, then we'll place this whole inside subarray in that position, then continue with the outer part. And I did the same in my code. This is the inside part of the portals, then I took the minimum of the inside part, then I kept the minimum, the lexicographically minimum possible cyclic permutation, you can say, kind of that inside part. Then I am just getting the outer part, and if at any position f I is greater than minimum and we have not taken the inside part, then we'll put all the inside part in the answer, and then we'll continue with the outer part. So that was D. Now E. Question E. Okay, so we are replacing x with yz. So the best strategy I told in my code, I think, was to, yeah, break. If this is 30, it is composed of different primes, different unique primes, then we will keep the largest prime with all, I can put all the larger primes in one box and keep this one, the smallest prime, in another. In this way, whatever you do, you will end up with a position where 3 will be, or 5 will be, before this 2. So that will not then it will not be possible to make the whole array non-decreasing, because there will be an inversion in this part. So that was question E. Now F was a pretty straight question. I think I did it, yeah, pretty quickly, I think. Okay, no, I did not. I am comparing these wrong answers. No, it took 1 hour. It shouldn't have taken that amount of time. It was easy question. Whatever. So I calculated the, okay, let me read the question once again. Exactly 1. So we can use that exactly 1 particle, or we can also avoid using that. So first we are checking for value in, like this y value is in. So we are taking this, we are sorting in the reverse order so that we get the n, y equals to n, then y equals to n minus 1, like that. Then we are calculating, okay, so for I equals to n, now this is sorted, so this will go till a of j dot first equals to I, like the y values are I. So in the first case n, then it will add all those numbers, then it will check the size, like if there are y greater than y plus 1 numbers or particles in that reactor, then it will be unstable. So we have to pop some numbers. It will pop until its size reaches I plus 1, that is the maximum capacity without collapsing. Then if it is not, the size is not I plus 1 exactly, then we can add more elements. So we can take the minimum possible contribution of an element to be 0, so that if we later add any element, the subtraction will be 0. Otherwise we will take pq dot top, the minimum value from the minimum contribution from the elements, then we'll just taking the maximum of them and putting in dp of I. Then prefix is to make the whole thing like the prefix sum, prefix maximum. In this way we're creating a gap, like we can put a value in that position. So I can, the ith the element with this y value can be put in anywhere between 0 dp of 0 to dp of I. So that is what we are basically doing. We are taking the maximum from dp of 0 to dp of y and adding x. That can be a possible answer, and other possible answer is we are not using this new particle, so that will be the previous maximum what we calculated here. So we will output the maximum among them. So that was it for this contest. Yeah, so see you in the next one.